Hey there, class. Today we're going to talk about section 1.5. We're just going to introduce some triangles and some special quadrilaterals. So again, it's a really definition-heavy lesson, but now that we're getting into some diagrams, there's some things that we need to talk about. When we look at diagrams in our books, you can't assume pretty much anything. Here are the only things that you can assume about the diagrams that you're given. That lines are straight. If two lines intersect, they intersect at one point, not multiple. And then points on a line are collinear. All points shown in a diagram are coplanar, unless they're drawn otherwise and purposely drawn non-coplanar. Okay, so those are really the only three things that you can assume, per se, about these pictures. Diagrams, we can't assume these things, that just because two lines or segments look like they're parallel doesn't mean they're parallel. The only way that we know they're parallel would be if I had two line segments here and they had these arrows drawn on them. That's the only thing that implies parallel. Same thing goes for perpendicular. If two lines look perpendicular, the only way we know that they're for sure perpendicular is if they're marked perpendicular. Angles, segments, and polygons are not congruent unless they're marked with enough information that proves that they are congruent. So again, if we're talking about line segments, we're looking for things like those marks. If we're talking about angles, we're looking for marks like this or this. Those are going to imply that they're congruent. If we're talking about polygons, maybe triangle ABC and triangle FGH. The only way that we can say for sure they're congruent is if they're marked congruent with the congruent symbol. Okay, so, and this goes for the rest of the book. At these statements, I'll go for the rest of the book. Okay, so now here we're going to just introduce, again, I said it's going to be a lot of definitions, probably ones you're very, very familiar with. You will want to make sure that you know these definitions because we have a quiz on 1.1 through 1.5, and I may be asking you some true-false questions that are in regards to a definition. Right triangles has one right angle. It's either going to be marked with 90 degrees or with that symbol there. We see that in our not right triangles, we have things that don't have 90 degrees or aren't even a triangle. Acute triangle has three acute angles. Acute angles, remember, are angles less than 90 degrees. Okay. If you have anything that is 90 degrees, equal to 90 degrees or greater, that makes it not an acute triangle. Obtuse triangles are the opposite. Obtuse triangles have only one obtuse angle. You can't have multiple obtuse angles. Remember, an obtuse angle is an angles that are greater than 90 degrees. So anything greater than 90 degrees, that could even include 91. And just again, remember that it needs to be a triangle, three sides. Scalene triangle has no congruent sides. So here we're actually looking at the measure of the sides. And then you'll see here, these congruent markings here tell us that those are all congruent, or here tells us that these are. Okay. Scalene doesn't matter about the angles. We're just talking about the measures of the sides. Equilateral triangle has three congruent sides. So they're either going to be marked with your congruence markings here, or you're going to be seeing them labeled out. The thing that we do know about equilateral triangles, that they are also equal angular triangles. So you'll want to make sure that you know that in the definition. Equilateral are also equal angular, which means that they have congruent angles. So automatically, you know, and this is by information given, if the sides are all equal in your triangle, your angles are all going to be equal. Okay, equal angles are going to all equal 60 degrees because if you only have 180 and you have three angles, they all have to equal 60. So equilateral means equal angular, 60 degrees. All right, isosceles triangle. It has at least two congruent triangles or congruent sides. So those again, you'll see marked here. And notice here we have an equilateral triangle, and that has three sides that are congruent. That still is an isosceles triangle also because it has at least two sides. Okay, the other thing we know here is about base angles, and we have vertex angle. Okay, base angle, let's talk about vertex angle first. Vertex angle is going to be the one that's between the two congruent sides. Those are going to be your vertex angles there. That makes the other two angles your base angles. So the one that's between the two congruent sides is your base or your vertex angle. The other two are going to be your base angles. Did I say that right? Let's say that again. Vertex angle between the two congruent sides. Base angle are the other two. All right, now we're going to talk about quadrilaterals. Remember, a quadrilateral is something that has four sides. So we have a lot of quadrilaterals to talk about. Okay, trapezoid. Trapezoids have exactly one pair, not on pair, one pair of parallel sides. Now, you probably think of the typical trapezoid that has these really nice congruent sides here, but we see that we have other trapezoids. They just have to have parallel sides. Again, parallel sides are marked here with the arrows. Not trapezoids, you'll see parallelogram. Okay, that parallelogram here is not a trapezoid because it has more than one set of parallel sides. A kite is a quadrilateral with two distinct pairs of congruent sides. Wow. That means that you have up, and it says consecutive congruent sides. Consecutive mean they come right after each other. So for example, we have here and here. These two are marked as congruent sides. So that's a consecutive pair. Here's another consecutive one. They come right next to each other. And that's marked with congruent sides also. Okay, you'll see in our other um, not kites, we have this one here. It has two pairs, two pairs of consecutive congruent sides, but they're not distinct because they're all the same. So that's something we're going to talk about soon. Parallelogram, it's a quadrilateral with two pairs of parallel sides. Okay, parallel sides are going to be the ones opposite of each other. Rhombus is an equilateral parallelogram. So a rhombus is a type of parallelogram. It has two sets of parallel sides, but they also happen to be equilateral. Remember, equilateral means that they all have the same measure. So we see that these are all congruent, and then we see that we have two pairs of parallel sides. Rectangle is a parallelogram, so again, it falls underneath the same definition, two pairs of parallel sides, but this one has four congruent angles. Again, these in a rectangle are all going to be 90 degrees because we only have a certain amount of degrees to split up equally, and so we end up with always having 90-degree angles in a rectangle. All right, a square. It's an equilateral rectangle. So it falls under the parallelogram. It falls under the rectangle, but then it also is an equilateral rectangle. So it's equal sides. It's an equilateral rhombus. Remember, a rhombus falls under a parallelogram. And then it's called a regular quadrilateral. Remember, regular means all angles congruent and all sides congruent. We talked about that in one of our previous lessons. All right, here is your work for that section. And remember, we are going to review and have a quiz on this. Thanks, guys.